NIT Kurukshetra. In fact, the topic that he is going to deliver is a very interesting topic, which he has been now discussing that many of the field engineers can adopt. And as he was telling that this is more of implementation rather than being a theory. So that's very nice of you, sir, for having joined us. Now, before I give it to the speaker, let me just tell the initiatives, speak about the initiatives that we have taken over the last few months. First and foremost, as all of you know, the Ramco Cements Limited, which is an organization in the Indian cement industry, started in the year 1960s. So we have seen the various technological developments, and we have been able to implement various technological initiatives in our cement manufacturing plants, the latest processes and whatever is it, right from mining till packing. You look at the surface area mining that we have adopted, which is environmental friendly. And as far as the grinding is concerned, in terms of implementation of vertical roller mill, in terms of implementation of various equipments for the manufacturing cement, we have been able to do that over the last few years. Now, Ramco Cements is not only in the field of cement manufacturing, as all of you know that we are also into the field of information technology. Ramco Systems, which by itself is an organization which is well known in the area of ERP. And we have been able to do a lot of initiatives in those areas. And we are also manufacturing dry mix products, and we are also having one ready mix plant in Chennai. And we are one of the largest wind energy producers in the country, because we are also having number of wind farms in the southern part of the country. So Ramco Group as such is a very old group, and we have been able to combine both the traditional as well as the modern technology within the organization, which has been able to help us in implementing various initiatives, and we have been able to collaborate with the construction professionals as well. Now, as you could see that we have had good collaboration with major construction firms like Lasna Tubro, ITD, Tata Housing, Gammon India, NCC, and our brand is also approved in all the metro projects, whether it be the Chennai Metro, Bangalore Metro, Delhi Metro, Cochin Metro. And we have also been able to supply cement where they have been able to make concrete of various grades in different exposure conditions. And in the eastern part of the country also, we have made a rapid stride, and we have been able to supply to major projects like, say, for example, the Arabian Construction Company, which is a well-known construction firm in the construction of multi-storied buildings. And we have also, our brand is also approved in Haldia Development Authority. So these are some of the initiatives. And in the eastern part of the country, our grinding unit at Kolaghat, we have been able to revamp it, in the sense that we have been able to expand its capacity from 1 million to 2 million, and our Orissa grinding unit is also commissioned. So that way we have good presence in the eastern part of the country. And during our interaction with the construction professionals, what we understood is that they are making various concrete grades in various applications and various ways they are making. You have the RMC plant, you have the site mixed concrete. So keeping that in mind, we have been able to customize cement, and now we have 12 brands of cement. Like we have the Portland Pozzolana cement, we have the Portland slag cement, we have the ordinary Portland cement, we have the SRC cement, we have the Ramco Superfast cement for precast works. So like that, we have even within PPC, we have the Ramco Supercrete cement, which is specifically meant for concreting works, which is having a high rate of gain of strength and low heat of hydration. And this has been specifically made for concreting works. Now it's a PPC cement, but it fulfills the requirement of high compressive strength as well as low heat of hydration. Then we have the Ramco Superfine EFC cement, which is primarily we are giving it the eastern part of the country. Ramco Supergrade, as all of you know, is the flagship company of the group, which is again a cement which has been able to help construction professionals to make durable concrete. Then we have the Portland slag cement, Ramco Samudra and Ramco Super Steel. And within ordinary Portland cement, we have Ramco OPC 43, 53. Then we also have a specific type of cement, OPC 43 Infra, OPC 53 Infra, which is specifically meant for concreting with long slump retention time, because when you have concrete to be transported, you need to have a sufficient slump retention time. Then we have the Ramco Super Fast cement, which is meant for precast application. Now, whether it is a hollow block, solid block, paving block, precast panels, one can go in for Ramco Super Fast cement, which is specifically meant for precast applications. Now, based on the experience of the precast manufacturers, they have been able to get a larger number of blocks per bag. And apart from it, the removal time of the mold has been very quick. which has been able to, which by itself ensured that it is economical for them in the long run. So whenever we make a quality product, the customer realizes that in the long term, there is a cost saving for them, because quality always means that, when you maintain quality, it's like, you are trying to save many costs in the future. So that is where our main thrust is. The Trimix product, we have a various range of Trimix products, whether it is Ramco Tile Fix, Ramco Block Fix, Ramco Superfine, Ramco Super Plaster, Self-Curing Plaster, and Tile Grout. So the basic idea of having a separate Trimix range of product is that this Trimix range of product is specifically meant for non-structural applications. So where we need to have different kind of parameters for them. Now all this is made possible because we have a research and development center at Chennai, Ramco Research and Development Center, which is also an NABL accredited laboratory, where we are doing number of tests on cement as well as concrete mix design. So we have a huge database of various concrete mix design, which has been where we have been able to do various concrete mixes with various different types of admixtures. As all of us know, that there are a number of admixtures which is available in the market, and one needs to ensure that the cement is compatible with different kind of admixtures. So that those are the initiatives that we have been able to take, and now we have been able to cover almost more than 104 webinars, since the lockdown started, and it is in the area of various topics, which is also available on YouTube, because what we believe is that our construction professionals should keep a track of recent developments that is happening in the area of concrete technology as well as civil engineering. Now, today's speaker, let me just give a brief introduction of him. Dr.Hari Krishna Sharma, who is a professor at Department of Civil Engineering at NIT Kurukshetra. He completed his BSc and MSc in Civil Engineering from Aligarh Muslim University and completed his PhD from NIT Kurukshetra. He is at present professor at NIT Kurukshetra. He has spent total 32 years in NIT Kurukshetra in different responsible positions. He was also head of the department. He had completed more than 3,500 consultancy assignments completed pertaining to structural design of various types of structures like bridges, buildings, overhead tanks, industrial structures, and other allied structures, inspection and testing of distressed structures, and material testing. He has also received many prestigious awards, to name a few. Award of Patent Tilted Slurry Infiltration Matte Concrete Plated Surface Structure by Patent Office, Intellectual Property India, Government of India in 2013. Outstanding Concrete Technologist Award by Indian Concrete Institute, Chandigarh Center in 2016. E.P. Nicolai Prize by the Institution of Engineers, India, Kolkata in 2007. So we have a speaker who is having experience both in academics as well as in consultancy. So I am sure that this combination will help us in tackling various challenges that the civil engineers is facing. So once again, let me welcome the speaker of the day, Dr. Hari Krishna Sharma, to share his experiences with us. Over to you, sir, and welcome again. Thank you so much for joining us.
So thank you very much, sir, for the introduction given by you. My topic for today's talk is structural application of advanced composites in retrofitting of distressed concrete structures. In fact, in this lecture, I would like to cover more of the application part rather than the theoretical aspects pertaining to the fiber reinforced polymers. Friends, as you know, the invention of cement in the mid of 19th century introduced remarkable changes in the construction industry. The cement concrete in the last 50 years or so has been used for various purposes and has become an important building material, not only for the ornamental purposes or replacing stones, but also for structures which were traditionally built with steel, since reinforcing it with steel became possible. Although recent developments in other alternate materials have been inroads into the spheres where cement concrete was used, it will be difficult to replace it in view of its low cost to strength ratio as compared with other materials, whether they are new or the old materials. The combination of cement concrete and steel has resulted in achieving architectural imaginations of our master builders, establishing long-lasting structure in a very short duration. The marriage between concrete and steel enabled reinforced concrete to attain significant strength in compression, tension, flexure, shear, torsion, and other force parameters because of the fact that both concrete and steel have developed good bond, although concrete is weak in tension, whereas steel is strong in tension. Both the material, that is concrete and steel, they have different properties, different coefficient of shrinkage, and say different model of velocity. Even then, they have developed good bond between concrete and steel. Friends, this bond, or you can say the marriage between concrete and steel, has failed. I have no hesitation to say that during the last, say, 20-25 years, I have seen many structures which have showed severe, say, distress in one or the other components of the structure. And the failure and the symptoms are now visible to the public or society in the form of, say, cracking of concrete, swelling of concrete, rusting of reinforcement, and the straining of concrete surfaces. The level of distress may vary from minor cracking to partial or complete destruction, as in case of marriage, that when the marriage fails, it leads to divorce ultimately. Many structures suffer not only damages where repair is possible and less costly than, say, 50% of the cost of construction. Identification of such kind of structures that can be economically repaired or retrofitted or require demolition must be made judiciously by a detailed engineering survey. Friends, before I go for some of the advanced methods or retrofitting methods used or to be used in the repair and retrofitting of loosely bonded marriage, or I can say the reunion of concrete structures, let us have an overview of some of the structural failures which occurred in India and abroad in the recent past because of one or the other region. You can see this slide wherein a number of buildings collapsed during an earthquake 921 in Taiwan, which occurred in 1999. Now, this building was basically a soft-story building. And as you know, the soft-story building is one in which we do not provide infill walls on the ground floor. So in such a situation, the buildings are, say, prone to earthquakes. And in earthquake, which occurred in 1999, a number of buildings, say, collapsed. Likewise, on the right-hand side, also you will find a building which also collapsed like anything. You can see the failure of structural members, individual members also. In this picture, you will find a column which was buckled because of discrete hacking of concrete column during interior renovation work. You can see that the column buckled at the, say, mid-height from the ends. And this is basically because of, say, the poor quality of the material or the poor design. You can say the failure of structural members, say in this picture also, the spelling of jetty pile cap concrete due to environmental. See, our concrete is prone to environmental effects also. And you can see the yellowish material, which is basically considered as the blood of concrete, which has come out. The concrete cover failed, and you can see that the reinforcement is clearly visible. Now, this was basically a bridge. In 1924, as you know, the Joseph Aspdin from Leeds, England, patented the Portland cement, and the material resembled just like a natural stain quarried from the nearby quarry. The first reinforced concrete building, a small two-story servant cottage, was erected or constructed in 1854 by Plastrier in UK, and the first bridge with reinforced concrete material was constructed in France in 1875. You can see that our concrete structures are prone to environmental effects also. And the left hand side, you can see that the reinforcement is badly corroded. On the right hand side also, you will find that you have a pier which was corroded and the reinforcement is there. There is peeling of concrete from this pier, and the reinforcement you can clearly see which is badly corroded. Likewise, if you say the distressed concrete structures which failed during the last, say, 25 or 30 years, you will find that concrete has been badly affected because of one or other reason. This has basically necessitated the retrofitting or repair of concrete structures. Common conventional techniques for strengthening reinforced concrete elements, like say concrete jacketing, shotcreting, or graniting, the steel plate bonding, these are basically the conventional methods which are quite cumbersome, messy, and time consuming. They are also labor intensive and require a lot of skilled work. And you know, now there is a problem of skilled labor too. In recent years, during the last 25 to 30 years, construction industry has seen increased demand in retrofitting and strengthening of existing structures because of the poor workmanship, the poor design, and the poor use of these structures. The poor maintenance of the structure is also responsible for the retrofitting and strengthening from time to time. And this may be attributed to various regions. The regions are well known, like say environmental degradation, the design inadequacies, poor construction practices, lack of regular maintenance, increase in loads, unexpected loading conditions, and so on. And fiber reinforced concrete is normally used to strengthen such kind of distressed members. Now, as far as the fiber reinforced concrete strengthening or retrofitting is concerned, as I talked about the various errors and mistakes which we commit during the design stage, during the construction stage, and during the service stage. As far as the errors and design stage are concerned, when we structural engineers are responsible for it, the design engineers are responsible for it. And many times we do not follow the codal provisions in totality. We commit some mistakes at the loading specifications, material specifications. We do not follow the design codes properly. And at a later stage, when we prepare the drawings, because the drawings are normally prepared by the draftsman and they also commit number of mistakes that they do not mention the grade of concrete, the grade of steel, what will be the development length, what will be the lap length, and so many other parameters they are not mentioning over the structural drawings, in absence of which the executor or the contractor will not be able to execute the structure properly. Then at the construction stage also, when we construct the structure, see, the structure which is designed by a well-qualified engineer who is BTech, MTech, and PhD professor with a lot of experience, we are designing these structures taking all precautions, and the execution is done by a layman. So during the construction stage also, there are many problems, like say lack of concrete cover, poor compaction, inadequate curing, lack of quality control, and insufficient site conditions, site supervision. These are the parameters which are responsible for various problems in the completed structure. Now, once the structure is complete, even after the construction is over, say we change the use of the building at a later stage. The structure which was designed for residential purpose, we are using that structure for say storage purpose. So when you are using a building designed for say residential purpose, for storage purpose, there will be definitely overloading of the structure. The building which are basically designed for store purpose, the live load is definitely different than those for the residential buildings. So this is basically that the change of use of the building. It is responsible for the distress of the structure. The environmental factors, as I told you, we have shared some of the slides which have shown the severe damage in the concrete and the reinforcement. The structural settlement and structural movement is also responsible. Say in case of say earthquakes or in case of the bridges, because of the longitudinal forces, there will be some longitudinal movement in the structure. And if proper expansion joints are not provided, it will lead to failure of the structure at the joints. So the lack of regular maintenance at the joints is also responsible for the distress in the existing structures. Now, with these three parameters which need or which necessitated the strengthening and repairing of the structures, let us come to the retrofitting of the structures using conventional methods or say the advanced method. As far as the basic objectives of repair or retrofitting of structures is concerned, the basic objective of any say technology, especially the technology used to repair or retrofit the structure, is to restore a defective structure back to its original state. That is the sole motto. Further, many times it is our objective to upgrade an existing structure, because many times when we change the use of the structure, it necessitates the upgradation of the structure for which the strengthening is required, and to improve or strengthen the existing structural members. Friends, as far as the repair or retrofitting process is concerned, if you look at it, you will find that the structural repair and retrofit is an engineering process. It is not a layman process. It is basically an engineering process. I can say that the retrofitting is basically an art as well as a science. So the combination of these two will lead to the engineering process methodology, and the process should have a holistic approach and should encompass a wide range of parameters related to the structure. So we should see the problem holistically, that is in totality, and the repair process should appropriately address not only the symptoms but also the causes of the distress. This is very important, that whenever we go for any kind of technology, we should see the problem in totality. What are the symptoms in the structure? What are the causes of the distress in the structure, and how this distressed structures can be retrofitted. Now, as far as the methods are concerned, the conventional methods for the retrofitting of the structures, all of us are well conversant. These are the pre-placed aggregate grouting, the steel plate bonding, the split concrete. You have the crack injection technique, and the latest, or you can say the recent technology in this area is the composite wrapping. As far as the pre-placed aggregate grouting is concerned, all of you know that it is basically nothing but it is basically the jacketing of the distressed structure. The steel plate bonding technology is known to us, and if you see, out of these methods, which method is to be adopted will depend on the factors affecting the structure and the degree of severity. One of the most important parameter for the selection of the method is the structural demand or the degree of deterioration. Now, this will basically decide the method to be adopted, whether we can go for the conventional method or some advanced method. So what is the structural demand? What is the damage in the structure? So that we can retrofit the structure to get back to its original state, or we can even enhance the structural strength for additional loads and stresses which may like to come because of change of use of the building. The availability of the budget is equally important, because when we go for the retrofitting of the structures, what say how much budget is allocated for say this purpose, and based on that only we can decide that a particular method is suitable. The accessibility of the site is many times of importance because of the fact that many times, say in case of repair and rehabilitation of the say control units or the control area of computer centers, and the office of the BSNL, many times you will find that the site is not easily accessible, and you can not remove the heavy machinery from that area. So you have to choose a method which can be adopted, say when the without moving the machinery installed in that particular area. Time factor is equally important, say because nowadays we are going for time-bound projects. So this methodology for the retrofitting the method should also be time-bound, and the cost-benefit analysis is to be performed to see that a particular method is appropriate or not. So as far as the traditional methods are concerned, friends, you know that it is nothing but in jacketing we are increasing the size of the member by putting additional concrete and additional say steel reinforcement. Now there are say many problems associated with this method, like say the method is bulky and setup requiring say formwork. The method is time consuming, labor intensive. Nowadays it is very difficult to get say skilled labor. The method is fairly destructive because say the structure which has already been distressed or say damaged, we are basically say disturbing that specimen by removing the damaged concrete, by removing the say damaged reinforcement. So we are further destructing the structure which has already distressed. Then improper bond between new and existing concrete is also one of the problem, because the concrete which was laid say 25 or 50 years back, say over the structure, that concrete may not be compatible with the new concrete. So there are problems. Say many times the concrete which has already been laid and hardened say is not say accepting the new concrete. So we have to say use appropriate type of say bonding material so that there will be a bond between the existing and new concrete. So this is also one of the drawback or disadvantage of this method. Then different rate of shrinkage of old and new concrete. We are putting additional dead load over the structure which has already shown distress. So this is not desirable. Many times the in jacketing method, say when we put the additional load, you will find cracks in the additional concrete itself. So this kind of problem is to be seen in totality. As far as the steel plate bonding, you know, the steel plate is basically say fixed by providing additional holes in the distressed structure, and we are again say damaging or destructing the structure which is already distressed. So again, these are some of the problems which are associated with the steel plate bonding technology. The method is requires bulky setup because the steel plates are very heavy. The method is labor intensive. The steel plates need to be tailor-made. That is, there should be a perfect leveling. And when you put your steel plate over the structure, there should be a proper contact between the steel plate and the existing concrete. Then it is hard to lift the steel plates and align steel plate with the structure. Drilling and bolting causes distress say in the existing structure. The welding of the steel plates with the existing structure is also a new kind of problem. And there is a problem of quality assurance, because many times such kind of treatment is given by not qualified engineers. They are normally given by a contractor who is not qualified or is not competent in the retrofitting technology. The sprayed concrete, again, we have some problems, and I'm not going into the details. They are more or less same. The method is shavy, and even uneven, you will find uneven surface finishing at a later stage. And the most important is that there will be increase in member dimensions. Say the structure, the concrete column, say, which was basically say 300 mm by 450 mm. After the split concrete, you will find that the member is has increased by about say 50 mm on both sides. So that is the problem. It means you are putting the additional dead loads. So that is again a problem. Now, as far as the crack injection technology is concerned, this method I would not like to recommend. This is simply a cosmetic treatment. Cosmetic treatments in the sense that the cracks in concrete are sealed or injected with epoxy resin, cement grout, or other suitable materials to prevent, say, ingress of atmospheric gases or to restore structural integrity of the element by bondings only. So it cannot be used for repair or to reinstate the element structural integrity only, and it has nothing to do with the enhancement of the structural strength. So it is it does not enhance the element original load carrying capacity. So I can say this crack injection technique is simply a cosmetic technique, and it will not significantly increase the load carrying capacity of the distressed structure. Say with these conventional methods, say some new or you can say the advanced retrofitting methods came into existence. One of the technology which came into existence was the steel fiber reinforced concrete, and this steel fiber reinforced concrete was developed in early 70s. All of you, being as a structural engineer, know that it is nothing but it is a concrete prepared by mixing, say, small discrete, say, small size wires, say, in concrete, and the maximum amount of, say, these steel fibers which can be added in SFRC is 2%. So at 2%, there will not be significant increase in the load carrying capacity, whether it is in compression, tension, flexure, or shear. So this kind of concrete, which was developed for the construction of conventional structures, as well as for, say, repair and retrofitting of distressed structures, say, did not work for a long time because the strength enhancement was not significant. So then came into existence what is called as the slurry infiltrated cone, the SIF cone. Now you will find that SIF cone is basically a different material, and the methodology for manufacturing of SIF cone is also different. That is, in this method, what we do is, say, we put say steel fibers, which may, say, be up to, say, 18 to 20% by volume of cone. So by increasing the percentage of steel fibers, say, there will be, say, tremendous increase in strength, whether it is in compression, tension, flexure, or shear. The methodology say, by which this material was developed was entirely different than that of steel fiber reinforced cone. That is, in reinforced SFRC, we mix the steel fibers in concrete itself. Whereas in SIF cone, the steel fibers were basically laid in the mold, and then cement and slurry was, say, filled and compacted. So by this technology, say, you will be able to increase the, say, fiber content, and with the, say, increase in fiber content, say up to 20% by volume of concrete, there will be tremendous increase in strength, in say, flexural strength, compressive strength, tensile strength, and so on. So this was basically, this methodology was also used for rehabilitation or retrofitting of these structures. Then, say, around 2005, the slurry infiltrated matte concrete was developed. I was involved in developing this material in the laboratory of civil engineering department of our institute. One of my PhD scholar developed this material. I have got a patent also on slurry infiltrated matte concrete, as informed by our moderator. This material, which is basically slurry infiltrated matte concrete, was basically developed by, say, putting, say, long fibers of steel of very small diameter, say 0.525 mm to 2.5 mm. And the length of the fiber was increased. So by increasing the length of fiber, what we are doing is we are simply increasing the aspect ratio. Now, say about 60 to 75% fibers are laid, say, in one direction, whereas 25 to 35% fiber were laid randomly, say, in the other direction, right? So it is just like conventional reinforcement. Say we put, say, the longitudinal reinforcement along the shorter span in case of slabs, and some reinforcement is provided in the longer span, along the longer span also, which is basically regarded as the secondary reinforcement. So the same concept was basically used to develop this material, wherein, say, 60 to 75% fibers were basically laid in one direction, and, say, 30 to 40% fibers were laid randomly in the other direction. And the cement and slurry with the, say, rich cement was basically injected or put, say, over these steel fibers. So by doing this, you will be able to get the strength, the load, you will be able to get the same strength, say, for, in case of slurry infiltrated matte concrete, at 50% fiber content than what was achieved in case of slurry infiltrated SIFCON. So the fiber contents were reduced to 50%. That is, say, when the strength which we got at 18% fiber content in SIFCON, we got the same strength at 9% in SIMCON. So this was a change in the, say, construction industry around 2005, and in 2013, we applied a patent for this, and we got a patent on this material, say, along with the application of this material in civil engineering structure for retrofitting. Then came into existence the fiber wrap system. This SIMCON, because of the, say, the large fiber volume content, say, was basically not found economical at a later stage. Many industries did not manufacture these long fibers. They were basically, they confined themselves with the production of only small length fibers. So we had some problem in procuring the fibers of longer length, of small diameter. Then came into existence the fiber wrapping system. And this fiber wrapping system, using fiber reinforced polymer, is the current basis of for the retrofitting of distressed structure. As far as composite wrapping is concerned, friends, the elements requiring capacity enhancement are jacketed or wrapped with fiber reinforced polymer. So by virtue of concrete confinement or by acting as additional reinforcement, the load carrying capacity is enhanced. So it is basically a very simple method, wherein the structure, the distressed structure, is basically wrapped from all around. And by virtue of the concrete confinement, that is, when you wrap the concrete, say, from all around, there will be confinement of concrete, and because of this confinement, the load carrying capacity will be enhanced. The capacity enhancements depend on the orientation of the fiber and the thickness of the composite onto the material. So the orientation of the fibers and the thickness of the composite material are very important parameters, say, in this technology, so that the strength enhancement can be worked out depending on the structural demand of the element. Now, the question came that why should we go for FRP components? As far as FRP composites are concerned, they have almost all the advantages of steel plates for plate bonding. The method is speedy and can be applied, say, with minimum increase in structural weight and size. In this method, you will find that there is a high strength to weight ratio. Fiber wrapping system is very thin, and you will find that there will be significant increase in strength, and there is high strength to weight ratio when this technology is applied. Lifting equipments are not required, and the method is also not labor intensive, because say only few people are required. Say few laborers are required to put or to wrap the distressed structure using this material. There is flexibility in shape, so any kind of structure can be retrofitted by FRP. The method can be held in rows, easy for wrapping on evaluated. So with these advantages, FRP composites are found better in comparison to the conventional method. There are again various advantages, as I talked about. The method is fast, intuitive, and no heavy equipments are required. It will mitigate several disadvantages posed by the concrete jacketing or steel plate bonding, and no additional dead load is put over the distressed structure. There are some limitations. Nowadays, there is only one limitation, that the method is a little bit costly. But if you avoid this parameter, because nowadays the thing is costly, the technology has already been developed, and it is basically a waste material from the aerospace industry. So presently, the method is also not costly. And if you see the cost versus time parameter, the technology is very much economical with respect to time. As far as the fiber wrapping system is concerned, the method was developed in around 80s by a company called Frp Company in USA, and it is basically an innovative method to strengthen structure. The materials were basically derived from aerospace industry, and as I was talking about, this is basically a waste product of aerospace industry. We are using high-strength glass hybrid systems consisting of e-glass fibers, Kevlar fibers, carbon fibers, and these fibers are basically embedded in epoxy matrix onto the structure. And nowadays, this method is accepted worldwide. As far as the history of this FRP system is concerned, the carbon fiber reinforced polymers was first used for the manufacturing of aeroplanes, and B787 plane was delivered to all Dipukon Airways on 25th of September 2011 using this material. And the first commercial flight started for this aeroplane on 26th of November 2011. Each plane was used 32 tons of carbon fiber reinforced concrete polymers, including 23 tons of carbon fiber. So you can say that huge amount of this material was used in the manufacturing of, planes, Boeing 787. The CRPF composites constitute 61% of the weight of the plane and 80% of the volume of the material. The plane consumed 20% less fuel due to the use of carbon fiber reinforced polymer. So you can see the economy in the fuel consumption because of the less dead load of the plane. As far as the carbon fiber reinforced concrete structure is concerned, this material was also used for high-speed intercity buses. You can find the frame of the high-speed intercity bus, which was basically made up of the FRP, the carbon fiber reinforced polymers. This was basically one of the steel-free floodway which was constructed first time without using the conventional reinforcement. This is basically one of the bridge, Sturgeon Bridge, which was constructed in New Zealand, and this bridge was built around 1996. Two spans, 163 meter, and the other was 61 meter. There were two spans. One span was having a length of 63 meter, other one was 61 meter. They are supported by a central A-frame tower. You can see the tower. This is basically A-frame tower over which this bridge was supported with 24 cables. And out of these 24 cables, two carbon fiber reinforced cables were also used in this bridge. So as far as this material is concerned, if you see the advantage, the application of this material, the material can be used for retrofitting or strengthening of building columns, beams, slabs, and walls. It can be used for the construction of slabs also. In slabs, the piers, the longitudinal and cross girders in case of bridges, in case of pile caps, in case of tunnels, in case of large and small diameter piping also. For steel pipes also, this method can be used for strengthening purpose. And for wooden and concrete piles, this method can also be used advantageously. In case of marine structures, you will find in some of the slides that this material was also used for jetties and works to strengthen these structures. So as far as the research and development in the area of fiber reinforcement is concerned, evidently there are some books available in the market, and you will find a book on fiber reinforced polymer strengthened reinforced concrete structure. And with this book will basically give you certain design guidelines for externally bonded FRP reinforcement for strengthening concrete structures. In addition to this book, you will find a number of research papers and the ACI code. This is basically ACI code 440, which was developed in 2002 and reaffirmed in 2008. This code is widely used for the design of FRP structures. So as far as the advantages of this method is concerned, as I told you, the method is non-destructive and easy to install, because in this case, you are not destructing the structure which has already been distressed. The material is very light and will be of only a few kg in weight. And it will not require heavy or special equipment, can be used in space-constrained areas because not much space is required, and can be incorporate different finishing coats, and it can be used underwater structures also. So in case of piers, in case of foundations which are constructed underwater, this material can be used advantageously. As far as the performance characteristics of this material are concerned, when you apply this material, see, whenever we design our structure, there are two considerations. One is the strength consideration, other one is the serviceability criteria. As far as the strength characteristics are concerned, in limit state, you have basically the limit state of collapse. And for serviceability, you have the limit state of serviceability. So by following the limit state method, if you see the first criteria is the performance criteria, and using this material, you can enhance the flexural strength of the members. You can increase the shear strength of the columns, walls also. You can increase the load capacity, the vertical load carrying capacity of compression members. Likewise, the method is also used to increase the ductility of the structure, which is of paramount importance in case of earthquake resistant structure. And under cyclic loading, this ductility, any increase in ductility will be an added advantage. The material is of very high tensile strength, and it does not corrode and can contain further corrosion of the distressed structure. because it is waterproof and it will not not permit the ingress of water or the penetration of water into the structure. So it will further contain the corrosion of the structure. As far as the application of this material is concerned, you will find this material, you will find nowadays FRP bars, which have replaced the conventional bars. The conventional means steel bars. So you will find these corrugated bars made up of fiber reinforced FRP. You will find these these bands or say U hooks which are provided to be used in different kind of structure. All these bars are basically, these bars are basically you can say the glass fiber bar, whereas the black bars are basically the carbon bars. You will find this material which can be used say for compression members also, and this material can be used as a formwork. We can leave this formwork say as such, and this material will basically replace the conventional reinforcement. Now, the material can also be used as a truss member in case of truss structures, for compression member, for tension members, for diagonal members, for vertical members, and so on. You will find the application of this part in case for say small jetties or small boats. Say nowadays FRP is widely used in other industries, and this boat was basically manufactured using this FRP composite. As far as the application of this material is concerned, this is a very interesting phenomena in the sense that the structure which you want to retrofit is to, first of all, to be prepared. And as far as the surface preparation is concerned, we remove the plaster and clean the surface, then patch up the surface irregularities, and all corners are basically rounded off to about 20 millimeters. So these corners are basically rounded, so that when you apply the FRP sheet all over the column, there will not be ingress of the atmospheric gases from the corners. Once the surface is prepared, then the surface is basically painted with some surface priming coating, and prime surface with a brush coat of this epoxy, and prime the soffits and sides of the beam and slab also with an appropriate epoxy. So once the epoxy, the surface is primed, then this fiber sheet is basically wrapped all around the. So wrap the member with the typho material after prime the surface. And once it is just like a bandage. That is, you can put this fiber map, this fiber reinforced polymer sheet is available in rolls, and so you can simply unroll the sheet, put a layer of the epoxy, and simply wrap the sheet over the distal structure. So it is just like bandage. And once this the distal structure is wrapped, you can leave this structure for about 24 hours for ambient temperature for curing. So no special kind of curing is done. You simply leave the structure for 24 hours. And after 24 hours, the structure, you can apply any kind of finishing coat and the structure is ready. So now you can see that there is a white coat, the finishing coat, and you can, now the structure is ready for use. Now this material can be used for different types of structural components, like say beams, columns, the slabs, and the foundation also. In case of retaining walls also, this material was advantageously used to enhance the structural strength. Now you can see the application of this material for the retrofitting of the beams. And the material was basically applied on the bottom as well as on the two sides of the beam. You can apply this material over the walls, and it is just like a wallpaper. You can put a sheet of the material over the wall and just fix it with, say, an appropriate epoxy. So it will look like just like a wallpaper. You can apply this material for retrofitting of slabs, and you can see that the application of this material for the retrofitting of slabs from the top, or you can say from the bottom as well, depending on the type of cracks which are developed in the structure. You can use this material either at the top or bottom of the slab. The material can be used advantageously, say, for the retrofitting of columns, silos, and chimneys. And you can see that this is basically a column, say, and you can simply put your FRP sheet all around this. So it is just like a bandage, as I wrote. Now the material is basically a blast resistant. So it can be used advantageously, say, in case of, say, bunkers and silo, which are normally used by our defense people. And you will find that this material can withstand a blast of significant intensity. As far as the code of practice for the material is concerned, we do not have any, say, standard code. There are, say, some guidelines from ACI Committee 440 and ICBO. AC 125 is also available. ICBO is International Conference of Building Officials Specifications for Concrete and Unreinforced Masonry Strengthening using Fiber Reinforced Polymer Materials. So this ICBO AC 125 is available, and using this code, we can design the FRP structures for the loads and stresses which will come over the distressed structure in future. ACI Committee 440 provides some guidelines for the design and construction of externally bonded FRP system for strengthening concrete structures. And this ACI Committee 440 basically provides that FRP systems must be developed through material characterization and structural testing as untested combination of fibers and ridges, which could yield an unexpected range of properties as well as potential material incompatibility. So basically, in such a situation, what will happen? You have to test a material, say, fibers in conjunction with the epoxy. Say, fibers are not tested separately, and epoxy is not tested separately. The FRP system is basically tested in combination. When fibers are basically, say, the fiber mat is basically covered with epoxy on both the sides. So any FRP system used should have sufficient test data showing adequate performance of the entire system in similar applications, including its method of installation. These are some of the recommendations of ACI committee, and with these recommendations, we can design a structure for the loads and stresses. ICBO approval is basically required for any new FRP system developed by any organization, and the criteria for ICBO must be met for issuance of approved material ICBO certification on fiber reinforced polymers. The material is tested comprehensively, as well as the system testing is required to obtain the approval as per ICBO recommendations and specifications. So this is another criteria for propriety of the FRP system. These are some of the physical properties of the composites which are required to be tested before applying this material onto the structure. Like, say, we have to go for the ultimate tensile strength, elongation, tensile modulus, coefficient of thermal expansion, etc. And all these properties are required, which will be tested as per ASTM standards. As far as the durability aspect is concerned, these are some of the tests, like say water resistance test, the salt water resistance test, alkali resistance, and say dry heat resistant test, which are to be conducted to ensure the durability requirement of this material. So these tests are also conducted as per ASTM standards to know the applicability of the material. As far as the Icbo requirements are concerned, the system tests are to be conducted when this material is used for columns, beams, slabs, or say for infill walls. And these tests are to be conducted in say, compression, tension, flexure, and some tests are also required to be conducted for the ductility. When this material is used for beams, then flexural and shear tests are obviously required. In case of slabs, which are basically flexural members, flexural test will be sufficient. In case of walls, the plain flexural and in-plane shear tests are required. And when the material is used for pipes, obviously the pressure test is required to be conducted. As far as this material was is concerned, the material was widely tested at National University, Singapore. And you can see that the columns and beams and slabs elements were extracted from an existing structure. And these elements were strengthened with TIFO and tested to failure. The actual failure load were compared with the theoretical design capacities, and it was found that there was significant increase in the load carrying capacity under different loading conditions. So when these materials were, these elements were extracted from the real structure, they were basically wrapped for testing in shear, in flexure, and in compression. You will find a control beam, which was basically tested. The design ultimate load was of the order of 268 kilonewton, whereas the beam failed over at a load of 326 kilonewton. The same beam was then strengthened with one layer of U-shaped steel shear wrapping with fiber anchors at 200 mm center to center. The design ultimate load was increased to 370 kilonewton because now the steel fiber, the FRP will also take some load. So this was increased to 370. And when this beam was tested, the failure load was increased to 440. So you can see that there was a significant increase from 326 kilonewton to 450 kilonewton with an increase in actual shear strength of the order of 37. So with a single layer of U-shaped shear wrapping, there was an increase of 37% in shear strength under shear. When the beam were tested in flexure, you will find a control beam which was basically, which failed at over a load of 25 kilonewton in flexure. And when this beam was strengthened using one layer of this FRP system, using some steps of this material, the design ultimate load was increased to 620 kilonewton. When the beam was tested, the failure load was 30.4. So there was an increase of failure load from 25 to 30 kilonewton with an increase of 22% in flexural strength using, say, one layer of FRP. In case of compression, the strength enhancement was significant, and say when this element was tested, the strength enhancement under compression was of the order of 49% using two layers of carbon shaped wrap. So when a two layers carbon wrapping was done, there was an increase in compressive strength by about 49%. So this is basically a significant increase in compression. As far as the ductility is concerned, in order to determine the ductility of the material was tested, say, for ductility parameters. This is basically one of the distressed column, which was basically tested, and you can see the hysteresis curve. You have a very small hysteresis curve, and the area under the curve is will basically give you the energy absorption capacity of the column. So for this, the ductility factor was basically of the order of 3 only. Now, when this column was, this is basically one of the definition of ductility, how ductility is defined. So it is basically the ratio of the deformation from a point of yielding to the point of ultimate load. So this is basically the deformation at the ultimate load, the deformation at the yield point. The ratio of these two values will give you the ductility. So for this ductility ratio, when this column was tested after retrofitting with the composite, the FRP, there was a significant increase, the tremendous increase, I can say, in the energy absorption capacity of the hysteresis curve increased significantly, and you will find the ductility factor rose to 10 from 3. So there was an increase in ductility factor by a magnitude of 3.3, more than 3%, 3 times. It means the material is significantly ductile and will increase the ductility of the structure when applied over the distressed structure. So this material was tested over in various universities and research centers, and primarily this material was developed in USA, and a number of universities like Colorado University, West Virginia University, University of Bologna, University of California, they tested this material for its application for these civil engineering structures. In India, IIT Chennai is actively involved in developing the guidelines and the criteria. National Institute of Technology Kurukshetra is actively involved in developing the design guidelines. We have already completed a PhD for retrofitting of the structures using FRP systems. As far as beam shear reinforcement is concerned, these are some of the slides wherein you will find this material, which was basically applied over for the beam and for the columns. So what is important in this slide is the orientation of the fibers. That is what is the direction of the primary fibers and what is the direction of the secondary fibers. ICBO clause for shear reinforcement for the flexural strength enhancement specifies that the fiber reinforced composite material bonded to the surface of the material or concrete or masonry may be used to enhance the flexural strength of the section by acting as additional tension or reinforcement. So it will simply act as an additional compression or tension reinforcement. And you will find this is a specific slide which has basically shown the orientation of fiber. Now let us say if you want to increase the shear capacity of the beam, then the direction of the beam fiber will be in this direction, so that there will be these fibers will take care of the shear. Likewise, if you want to increase the flexural capacity of the beam, then the direction of the beam fibers will be in this direction, and the direction of the secondary fibers will be perpendicular to this. So that way we will be putting these fibers in the main direction as well as in the secondary directions to increase a particular type of the load carrying capacity. This is basically in this picture you will find a clear idea about the as far as the T-beams are concerned. So you can wrap these beams from all around, and then at the ends you can put the fiber anchors. These anchors are also made up of FRP, and they are put so that this sheet at a later stage will not come out at the ends. So this is simply just like providing additional development length. So these are some of the anchors. I am skipping this slide. As far as the analytical aspects are concerned, as I told you, the flexural capacity of FRP strengthened slabs has been investigated by many investigators, and they have provided the design guidelines to calculate the flexural strength of slabs and beams, etc. The slabs are also flexural members just like beams, and we analyze these slabs like beams only. So in case of a beam which has conventional reinforcement, and say if this beam has failed, that you have, say, when this beam is retrofitted using a FRP plate, say at the bottom, right, or on the sides also, then you can see the strain diagram, the stress diagram, and using these stress strain diagrams, along with the compatibility equations, you will be able to calculate the load carrying capacity or the moment carrying capacity of the member. Now, these are some of the expressions which may be used to work out the moment carrying capacity of the members using FRP composite. As far as the installations of this material is concerned, initially this material was used in USA, then this material came to Singapore, and the people from the Nanyang University in Singapore and the National University, they started research and development work on this material. In India, this material came from Singapore through their agencies. As far as the application of this material onto the structure is concerned, in civil engineering, there are basically 4 terms as far as the repair and retrofitting area is concerned. One is the repair, then the restoration, the strengthening, and the retrofitting. Now, these are the 4 terms which are many times vaguely used vaguely used in civil engineering. If you see repair, it is nothing but it is basically the technique used to bring back architectural shape of the structure. It had nothing to do with the strength enhancement, and it is simply a cosmetic treatment. Then comes the restoration, which is nothing but to restore the original strength of the structure. So the capacity of the structure will not be enhanced. The structure will come back to its original strength. And this procedure is regarded as restoration. Then comes the strengthening, wherein you will find there is upgradation of the structural strength to make it capable of resisting probabilistic future load. So when you go for, say, change in use of any structure, we should go for the strengthening. And this term is regarded as strengthening of the structure. And lastly came the retrofitting of the structure, which is nothing but the addition of 1 or more members to increase the moment capacity or load carrying capacity of the structural members. So with these 4 terms, we should use these terms very precisely. That is, when we are going for the strengthening or restoration or retrofitting of this. As far as the application part is concerned, this is one of the, HDB building, which was basically used as car parking in Singapore, and the building was upgraded using this material. Now, the building was found deficient because of increase in loading. This building was basically added 2 more stories at a later stage. And when the structural engineers checked during the structural audit of the building, it was found that the building is deficient because of the addition of 2 stories. So then this building was retrofitted using FRP technology. You will find the application of this material over the beams as well as over the columns for the same building. The retrofitting of this column using, this was basically a ground floor column, which was retrofitted using this. And you can see the finished column. You can see that this technology was used for retrofitting of the slabs, which from the top as well as from the bottom. You can see that this material can be used in steps. It is not necessary that you put this material, say, over the entire surface. Depending on the structural demand, you can put strips also, say, over the structure if the full covering is not required. So that is to be decided based on a detailed engineering survey using, say, appropriate non-destructive, say, testing technology. Again, so this is basically the completed structure, and the structure was basically retrofitted using this technique. This is basically an international building in Singapore which was upgraded, and it was found that a low concrete gate was used during manufacturing. So when the structural audit was conducted, it was found that the building needs retrofitting of most of the structural elements. So then the building was retrofitted using appropriate technology. You can find, say, some of the elements which were found, say, corroded, and the reinforcement was visible. Again, say, this was one of the hotels in Singapore which was basically retrofitted using this technique. You will find in some of the pictures the retrofitting of the beams, say, for flexure and shear. You can see this kind of strengthening for columns and beam. It is simply wrapping of the beams and the wrapping of the column from all around. And you can see the orientation of main fibers and the secondary fibers. This is very important because the strength enhancement will basically depend. I am again emphasizing this point that the orientation of the fibers is very important, say, in order to achieve say, appropriate strength enhancement. So the strengthening of walls was done, and you can find out the completed structure in a very beautiful shape. This is basically one of the building, MTRC building in Hong Kong, which was basically retrofitted using this technique. And the building was found deficient because of cracking caused by vibrations. Machinery was basically installed in this building, and because of lot of vibrations, there were severe cracks in the building. So using this technology, this building was retrofitted. This is one of the car parking in Malaysia, and more than 20 beams were retrofitted for shear and flexure using this technology. Again, you will find some of the bridge. This is the bridge in Bangkok, Thailand, wherein you will find that a number of structural components were found deficient. You can see that in this girder, the reinforcement is exposed because of this severe dampness in this area. The concrete cover came out, and there was severe corrosion in the reinforcing bars. So because of this corrosion in the reinforcement due to saline environment, these components were retrofitted. Likewise, this is basically one of the bridge in China, again, which was retrofitted using this methodology. This is an arch bridge, which was basically retrofitted using FRP system. Just after the design, when this bridge was constructed, before the bridge was put to use, it was found that the bridge is under design. Some of the loads which were supposed to be included in the design stage, they were not included inadvertently. So because of this, the bridge was found deficient, and this bridge was retrofitted using this technique. Again, these are some of the structures, jetties in Hong Kong, and we can use this kind of material for wooden piles, for steel piles, and for other structures also. The seismic strengthening of the structures and for corrosion protection of the structures can also be achieved using this technique. This was basically one of the airport building, airport structure in USA, which was retrofitted using this technique. These are some of the structures, the pipes, which were found corroded, and using this technique, these structures were using carbon fiber wrapping system. You will find some blackish material. It was coated all around the steel pipe, to check the corrosion of the steel. Again, you will find some of the pictures of the structure which were retrofitted in Malaysia, in Canada, in USA also. This is one of the chimney which was retrofitted using this technique in USA. And you will find, this is basically the original shape, original chimney, wherein you will find that the reinforcement is visible, the reinforcement came out, the cover came out, and there was severe concrete deterioration in chimney. So this chimney was retrofitted. This was basically of historical importance, for USA. And this chimney was retrofitted using this technique. So once the retrofitting was done, you will find that all the exposed reinforcement was covered using this technique, and the reinforced the building, the chimney was looked like this. You can see these are some of the structures in Taiwan which were retrofitted. The silos which was retrofitted using this technique. This was one of the bridge in USA which was retrofitted using this technique, and it was found that this code was found deficient because of change in codal requirements. So because of the deficiency found because of the change in codal requirement, this bridge was retrofitted, and there was no damage found in this bridge even when an earthquake of 6.6 magnitude came in California at a later stage. So at 6.6 tremor, there was no damage to the retrofitted structure. So these are some of the buildings, General Instrument in Taiwan, which was retrofitted. In India, we applied this material to retrofit Shah House in Bombay, and the strengthening of flat slab and circular columns was done, which were found deficient because of severe corrosion and low grade of concrete used during construction. So you can see that the exposed reinforcement over here. Likewise, at the junction of with the floor, you will find that the reinforcement is corroded and exposed. So these structural members were retrofitted using this technique and successfully. Now, this is one of the building in Bombay, the City Telephone Exchange, which was retrofitted using this building. See, as far as the telephone exchanges and important structures, housing, important machinery, there are certain requirements. That is, the technology which you are going to use must be dust-free. No disruption to the existing telecom services and reduction in the frequency of regular maintenance. So in order to avoid these, or in order to use the methodology under these circumstances, this method was found appropriate, and the building was retrofitted using this technology. This was at Chennai, one of the Indian Oil Corporation storage tank was retrofitted using this tank. The tank was found corroded, and for corrosion protection of pipes of firefighting system, this system was adopted because the liquid was, the fuel was already there, and we cannot go for hot water or hot work which can be carried out. So we have to go for a technique which can be used under cold environmental condition. And the technique should also be economical and will give you long-lasting solution. So this tank was basically retrofitted using this technique successfully. You will find some of the buildings with columns which were retrofitted in Delhi also. The retrofitting of the column you can see in these pictures. And for some of the telephone exchange buildings in Bombay, this technique was also used successfully. A bridge, the telephone exchange in Bombay was also retrofitted using this technique. Some quarters were retrofitted there were some structural members like say beams, columns, and slabs which were found severely damaged, and this technology was basically adopted for retrofitting of those structural elements successfully in Delhi. You can find that the priming is going on, the wrapping of the columns in progress. This method was also adopted for the structural repair and rehabilitation of Janak Setu in Delhi. So this bridge was repaired and retrofitted successfully. You can see the distress in the fractural member. At bottom, the reinforcement is visible to you. The longitudinal girder is in a very bad shape. So these structures were retrofitted successfully using this technique. You can see the work is going on this bridge, and this work was basically completed successfully, and the bridge was put to use later on. As far as the seismic strengthening is concerned, although I have showed you many slides earlier, these are some of the slides which are basically used for, say, multi-story buildings, say, when the structures damaged during the earthquakes. And say, this technique was used to increase the, say, flexural capacity, the ductility, and other force parameters, say, for the distressed structures successfully. You can see the cracks in the buildings, in the columns, the walls, and using this technique, these structural elements were retrofitted successfully. As far as all the school buildings were also retrofitted successfully, you can see the slab portion of the building, and there was severe cracking and the peeling of concrete from the beams and slabs. So the reinforcement, the concrete cover came out, and the reinforcement was visible, say, in the beams and the columns. So using this technique, these structures were also retrofitted successfully, and they were put to use at a later stage. You can see the finished surface of the longitudinal and transverse beams after the completion of the retrofitting process. You can see some of the staff quarters of a number of buildings which were retrofitted using this technique. This building was basically, this technology was used for retrofitting of overhead tanks also. In say 2015, overhead tank in Ahmedabad was retrofitted. I was involved in as a structural consultant, say, to advise appropriate method for the retrofitting of this tank. And I provided the methodology, the structural design, and the procedure for retrofitting of this tank. And using the appropriate procedure, this tank was retrofitted using this technology. And after, say, 7 or 8 years, still this bridge, this structure is working well. And I hope that this structure will also work well for another 25 to 30 years. So these are some of the slides for this tank, which was retrofitted successfully using this technology. So in a broad way, we can say that the FRP technology can be used successfully for the strengthening or retrofitting of distressed steel or concrete structures, and the need for strengthening of repair and retrofitting is to be ensured by going detailed survey for the distressed structure. The repair and retrofitting of structures using composite technology is an appropriate technology, and the appropriate methodology basically depends on type of failure of the structure. The repair or the strengthening of damaged but repairable structure is advantageous for long-term recovery of community than reconstruction. As I talked about earlier, that the structures which can be retrofitted at less than 50% of the cost of the original structure can be retrofitted successfully. Now, if the cost of repair is more than 50%, then it would not be wise to go for repair or retrofitting of the structure, and it would be better to go for a new construction. The damaged RC structures can be repaired as well as seismically upgraded using a special technique. The success of every scheme basically will depend on three basic parameters. This is very important. Conclusion I can say, the basic aspect is the detailed engineering survey and the analysis of the structure, which must be carried out by a qualified engineer. The selection of appropriate scheme for repair, including strengthening or retrofitting of the existing structure, is to be decided by the structural engineer. The FRP strengthening has been accepted as a mainstream technology all over the world, although the methodology has required some more research in this area. We are still not knowing the strengthening with the pre-stress FRP reinforcement. So this is basically a gray area in which the research is required. A lot of research is required. And the performance in severe environmental conditions is again one of the area which require further studies. Because many times in severe environmental conditions, I have personally seen when we worked on some beams for retrofitting, and those beams were put under normal temperature, in an open area for 2-3 years. I found that there was some debonding of FRP from the surface. Now, this area under severe environment need to be investigated. The performance under extreme loading condition is also like blast loading and impact loading. This is basically another area in which we are working nowadays. My two PhD scholars are working to investigate the performance of this material under extreme loading conditions. FRP-enabled hybrid structures offer many opportunities for innovation in structural forms. So hybrid structures can also be constructed. FRP composites have an excellent future in bridge and buried structures also. So this is, I can say, this is basically the future material for civil engineers. And long-term performance and life cycle design are crucial for future successes of this material, particularly as a new construction in the new construction area. So these are some of the conclusions out of the studies conducted on FRP technology for repair and retrofitting. And I must thank my collaborators and the members of my research group, who contributed a lot, in this area, and they are working hand in hand with me to develop new technology and to study the performance of this kind of material under extreme loading conditions, under severe environmental conditions, and so on. So with this, thank you very much. Thank you. I would like to convey my sincere thanks to the organizer, the Ramco Cement Limited, for organizing this wonderful webinar, international webinar, for the benefit of field engineers, for the academicians, for the students who will be able to understand this topic. And I would be very happy to answer the queries or the questions from the audience. Thank you very much. So yes, sir. Should I open my video and audio?
Thank you, sir. Thank you very much, sir. Because of bandwidth issues, there has been a little disturbance at the later end of the talk. And unfortunately, Anil sir had to leave because of his prior commitments.
Hello. Hello. So is there any question from any quarter? Hello. Hello. भाई कोई नहीं वीडियो बनता है Am I audible, sir? Am I audible?